So hopefully this formula looks familiar. Do we all remember the distance formula?
Yes.
A little bit? All right, distance formula. So the distance formula is one of the formulas that is used a lot. The first thing that it comes from the Pythagorean theorem. So instead of doing the Pythagorean theorem over and over, like having to do find this and find that, they're like, oh, it's a formula, guys. Ta-da, it's called the distance formula. So if you know where you're starting and where you're ending, you plug in those values and wham, bam, thank you, ma'am. You have your distance, okay? So distance formula, if you don't know by heart, should this be something that's in your notes? Probably so, okay? Middle school. Distance formula was middle school. Yeah. Should have been in middle school and then revisit it in Algebra 1. Okay, so the beauty about formulas is that some real bored person found all the patterns for you and then made it easy on your life, right? So let's practice using the distance formula. So here we have 2 points, 3, -4, -2, 7, and we want to approximate the distance to the nearest 100. Okay, so you have your x1, your y1, your x2, your y2, and all you have to do is plug them into the formula. So D equals the square root of -2 minus 3 squared plus 7 minus -4. Feeling some familiarity yet? So we keep going, and we have -2 minus 3 is going to give us -5. We have 7 minus -4, which is going to give us 11. When you square a negative, it becomes a positive. And we're now at the square root of 146. And we're going to find that approximate value by typing it into the handy dandy calculator. And we get, anyone, somebody, everybody? I would be, I'll tell you, 12 8/800 is your answer. And it's at the nearest hundreds, which makes sense because what's 12 squared? 144. So, all right, can we do the distance formula? Yes. Anyone's like, ooh, I need a little practice.
No.
Okay, cool. Now, our next formula, midpoint formula. So distance and midpoint should have been learned roughly at the same time. Your midpoint is when you're trying to find what's smack dab in the middle on an ordered coordinate plane. So you're still labeling x1 and x2 and y1 and y2. But this time you're coming up with a point, not a singular value. Okay, ringing some bells. So, ready for an example? All right, let's look at an example. So if I said find the midpoint of the line segment connecting the points 6, -7, and -4, 6. So you have your x1, y1, x2, y2, and you're going to substitute these values in to find the midpoint. Midpoint is always with a capital M. Lowercase m means what? Anyone? Slope.
Oh, that's right.
Lowercase m means slope. All right, so we end up with 2 divided by 2 and -1 divided by 2. So our midpoint is at 1 and -1/2. Do you feel like finding the midpoint is something you can confidently do?
Yes.
If this is on your quiz next week, do you think you can do it?
Yes.
That's good to know. All right.